Okay, please.
Yes, we are here.
Okay, yeah. Now it's your turn. Yeah, can you share the screen?
Shall we play the video first?
Yeah, you can. By 8
Okay.
minutes. Okay, total.
Okay, okay.
Yeah.
Professor John, can you hear the voice of our video?
Yes, the voice was fine. The audio was okay.
OK OK，从头重放一遍，他们可以听到。从头重放一遍吧。Good afternoon, distinguished judges. I feel sorry that due to the influence of COVID-19, I didn't make it to the coastal city Qingdao. 在干什么？那你赶紧放啊！我刚刚已经在说开场白了。Sorry, something is wrong with our computer. Sorry. Okay. I have always been longing for the beauty of the ocean, and I was looking forward to seeing it in Qingdao originally. To explore the deep mystery of the ocean, pioneers have made efforts in the field of underwater vehicles. Difficulties will inevitably occur during the process of marine exploration, and one falls on the endurance. With the vastness of the ocean, endurance has been limiting the exploration scope of underwater vehicles. Researchers have figured out solutions from more efficient energy supply, to more proper structures, while we tried to find the answer from the ocean. Last summer, when I was sailing, a flash of light suddenly struck me. Now that the air and the water are both some kind of fluid, can we imitate the principles of sailboat? Or can we just make full use of the water flow as we did with the air in sailing? It is proved that we can, and this is our work. The ultimate goal of our work is to improve the endurance of underwater vehicles. To start from here, the production must satisfy these conditions. Firstly, it must be able to function as some kind of propeller powered by water flow. Secondly, its weight is comparatively lighter than other structures. Thirdly, the body shape performs great resistance properties. Fourthly, the surface area is big enough to be propelled. Also, its struggle is stable underwater. Based on these considerations, we combine the concept of sail and blended wing body and designated our system as wing sail. The adoption of sail from sailboat provides us the solution to the fundamental problem of propulsion, while layout as blended wing body in the industry of aviation means integration of wing and body, which can meet our requirements to some great extent. After analyzing the force withstood by underwater vehicles, conclusions can be drawn that the force is divided into lift and resistance. Within certain range of angles, lift is functioning as some kind of propelling factor, and experiments results assist us in setting the most appropriate degree as 30 degrees. On the grounds of theoretical support, it can be concluded that by adjusting the angle of attack of wing sails, the lift of water flow can be used as a propelling factor for the underwater vehicles. Upon overall design and force analysis, here comes the product. Wing sail is located in both left and right side of the wing, and each of them is divided into two layers. The wing sail is foldable. When it is folded, the traditional power system will be adopted. Once the ocean current sensing module perceived appropriate current condition, the wing sails will be unfolded. Each of them can be controlled separately to adjust to the orientation of ocean current so that the power of water flow can be utilized at maximum. Exceptional circumstances have also been taken into consideration. When ocean current is unstable or one of the wing sails is broken, the wing sails will be folded automatically to keep the stability of the underwater vehicle. So far, the wing sail device has been functioning as a propeller driven by water flow. Comparison results. Yes, we can. Sorry. Comparison experiments on traditional underwater vehicle and the one with wing sail demonstrates that with the equipment of wing sail, the lift can be increased by 30% to 50%, and hence the endurance of underwater vehicles will gain in a corresponding increase. Field tests also provide proof for this result. In the process of creating this work, we have been dealing with data and applying theories. Those are rational things. However, with future application in ocean development and research, by applying natural resource to explore natural resource, we try to convey something emotional. Our curiosity for the ocean, our respect for the earth. Thank you for listening. Okay.
Yes, A very nice project. So I understand that these wing sails, that the shape of the wing sails can also be controlled for the navigation. So how is this actually done? So excuse me that I did
So
not.
how we determine the shape of the wing sail?
Yes, and how
due
you
to
actually
the
implement it.
Okay.
How?
Due to the thin air foil theory, we know that there are three factors that can affect the lift of the wing sail. They are thickness, camber value, angle of attack. And among them, the angle of attack affects the lift most. So we mainly consider the angle of attack as the contributing factor. And we set the thickness is uniform. And we, by simulation, we calculate the lift coefficient to draw the conclusion that at 30 degree, when the angle of attack is at 30 degree, the wing sail will gain the largest lift.
Okay, thank you. I have two questions. What is the size of your device, and how do you do the deepness? So how do you control how deep the device is going into the ocean?
We mainly focus on the endurance of underwater vehicles, but we underwater conducted experiments on the depth of the underwater vehicles. Now we set the depth of underwater vehicle at about 300 meters.
And how big is the device?
This is our device. These are our device. Can you see it? We have 3 generations of wing sail device, and
we cannot see. We cannot see that.
Sorry,
we only can see you.
Sorry. I will. Oh, okay. I will explain them in words. We have 3 generations of wing sail device. The first generation is almost a prototype. It can't actually work in the water. In the second generation of our product, we apply the gear-driven system in the mechanical transmission, and it can actually work in the water. And the third generation, with the third generation, we do the field test, and we improve the surface area of wing sail and make it larger to gain the lift.
Okay, thank you. Other questions from the jury?
Yes, could you explain that the power? What is a power source, and how do you control that your devices?
Oh, okay. We assume that our underwater vehicle is moving against the current, the ocean current. That is the condition. According to the theory, we can divide the force withstood by our wing sail into lift and resistance, and we do some analysis on force, and we. By the water flow, we use the power of water flow to drive our underwater vehicles. When our wing sail device is folded, it will be driven by traditional power system. But when the sensing module perceived appropriate current condition, it will be unfolded, and they will be driven by water flow, by ocean current.
Mm-hmm. So, but how do you open and close your wings?
Sorry, beg your pardon?
How do you open your wing and close your wing?
It will be controlled automatically. We have sensors and
only
control
for
system.
Only for that the flow?
Beg your pardon?
only the flow can control that wing open and close?
No, not the water flow. We have a sensor module, and it is the central part of the system is gyroscope. And when the current situation is appropriate, the wing cells will be unfolded by the control system, not by the water flow.
So what is a power source for the gyroscope?
Inner power system, inner batteries.
Battery.
Yes, yes, they also have a traditional power system, and those are electrical modules, and they will be powered by inner batteries.
Inner battery. Okay, thank you.
Thank you for your question.
Yeah, thank you.